Hello and welcome back to K-Tech Designs. My name is Seth. In this tutorial, we're going to actually look at using Autodesk Fusion360, the personal license, to model a fidget spinner. Now, I've known about Fusion360 for a while, and I've just been reluctant to use it because I've always had access to SolidWorks. In my search to have a home CAD package, I came across FreeCAD, which seemed pretty nice, and I've been using it for a while. But honestly, I'm still dissatisfied with it. So recently, I picked up Fusion360, and I gotta say, I am really happy with it. It's got, the basics that you need. Revolves, extrudes, sketching. It's very intuitive. It's very easy to use. It's a very strong CAD package. Autodesk has been around for a long time, so they know what they're doing. One of the limits I have found is that you can only have 5, or you can only have 10 editable documents at a time, but that's not a big deal. You just change it. File from read-only to editable, and you can get those back. Okay, here it is, yep. And you can get that file back if you want to make it editable again. So it really doesn't have that, much of a limit. You can get around it. What else is nice is a full list of your save history. So every time you save a file, it creates a version. If you mess something up, you can look back in your previous versions and see if that's the one you want to keep. This will be a project video soon. I'll leave that for the video. Anyway, on to the video. I'm going to show you how to model a fidget spinner in Fusion. Should be a pretty simple project. Let's get started. So right away, I've made some changes to the default. I don't really like seeing the layout grid, so I don't have that on anymore. Snapping to grid is not that useful to me, so I don't have that on either. I guess that's about it for personal settings. To get started, let's just create a sketch. Here's a sketch button here. I'm going to do it on the top plane. So the grid does come in when you edit, when you create a sketch, and I left it, I guess. I didn't really look into taking that off. It's not that big of a deal. The first thing we need to do for this fidget spinner is create the center body. Sketch dimension. This is going to be 34 millimeters. I believe the default unit of measurement for Fusion is metric. Of course, you can go into settings to change that. That would be over here. Preferences. So your user preferences. And then you can navigate to the units there. Back to the model sketch. The bearing I'm using is a 608. And the OD on that is 22 millimeters. So I'm making a press fit design here, no clearance. The tolerance of the printer, I guess the tolerance of whatever your printer is could determine whether this is actually going to be 22 or not. I'm using a Prusa original i3, Mark III i3, whatever. And I found 22 millimeters was a pretty snug fit. It wasn't too hard to press in, even by hand. All right, so that's the main body. So let's finish that sketch, extrude it. Now, one thing that's a little different about Fusion, I've noticed, is it doesn't grab onto your sketch and understand which surface you're trying to extrude to. Like in SolidWorks, I would just pick a sketch, pick extrude, and it would automatically select this ring, which is what I want. But in Fusion, it wants me to select the profile, which isn't horrible. It's just a different kind of way to do it. It's really easy to drag your extrusion length with this feature here. That's something you can do in SolidWorks as well. It's called Instant 2D or Instant 3D. In SolidWorks, I generally don't like doing that. I'll just key it in. Same with Fusion, I tend to key it in. But since I know it's 7 millimeters and it's incrementing by a millimeter instead of like a half or something, this was easy enough. A little bit on the extrude feature here. This is actually where you can create a boss extrude that joins with an existing body, or a cut, or you can do an intersection. You can make it a new body or a new component. So there is no separate cut feature. There's just extrude, and it's either a cut extrude or a boss extrude. The defaults here are what I want. You can also do a taper on the model. So if I wanted it to be like, I got to figure out how to rotate properly. You see that it creates a tapered feature, but that's not what we want. So you come down here if you want to edit your model features, and we'll get rid of that. All right, that's looking pretty good. Let's create another sketch, make it on the same plane. And what we want to do is create our wing, I guess I'm calling it. This wing is the same size as this, but a little bit offset. What I might want to do is hide. So this is pretty neat. If you need to hide a body, you toggle this eye image here. If you want to toggle the sketch, it's the same. So this will allow me to, let's see if I can make these tangent. Okay. Let's make these horizontal. Let's make this a vertical member. All right, that looks good. So now I need to create my distance between those two, which is 27. Oh my goodness. Two, 7. Now we need this surface here, so we'll use our trim tool. We can trim that and trim that, and that gives us our profile. So now in Fusion, we don't actually have to create a line here. We don't have to create an arc here. We just use this profile. It's smart enough to recognize this sketch back here and this sketch here and create a boundary between them. So I can bring that back. Pad, it's not a pad. I'm stuck in FreeCAD terminology. Let's make it 7 again. And you can see the operation change from new body to join. It recognized that these two bodies were next to each other, so it's going to create a join, and that's exactly what we want. And then click OK. Now I actually have to come back in here and create a hole for the weighted bearings. So what I'm going to do for that is I'm going to go ahead and hide the body again. Bring back this sketch so that I can attach to that center. And then of course, this bearing is the same bearing as 608, so that's a 22. You can see that the reason why I had to put this sketch in after the fact is because I have to cut into this first ring with the placement of that. And that is just because the overall dimension that results from here fits really nicely in my size hand, I guess, but it forced me to have to model it this way. Instead of making, the center distance instead of 27, maybe like 30 or something, this was a nice tight fit. Anyway, let's create our cut. So we create this, and then if you drag it down, you can see that it changed the operation to cut automatically. I don't know if this, yeah, so you could do a through all, and it'll automatically pick the dimension. You don't have to key it in. And that's kind of nice because if you ever change the thickness of this model, you want that cut to be all the way through. We don't need to mess with that right now, but I'm going to leave it at through all and cut. Okay, now we actually want to take these two features and make a revolve. So we need to, the rectangular pattern is the default, but in order to get to our polar pattern, click on create and go to pattern, circular pattern. Type is feature, that's correct. Two selected objects, that's correct. We want to pick this axis, and 3 is actually what I'm looking for. All right, that looks great. The next thing we want to do is to fillet these corners. So we'll create a fillet. I want this one, and this one, and that value should be 8. Okay, that is looking fantastic. The next thing we want to do is to take care of these edges. Now you could just put a fillet on either corner or on either edge. Same size, like 3.5 millimeters, so that'll be a full round. But you could also change your fillet type to a full round fillet. Now the way you do this is by selecting this face. Sorry, not that face, for this face. And it'll create this nice fillet without a center line between them. You also don't have to pick the size of the fillet. It'll always just be whatever the thickness is. Okay, so that's pretty much done. The only thing I want to add are some chamfers to these holes to make the bearings easier to go into. So we go down, modify, till we find chamfer. Yeah, 45 should be fine. Pick all your edges. I'm sure someone will point out, and this is also valid, that you could have done a chamfer on this hole here and revolve that. I like to do chamfers and fillets at the end of most of my modeling. Sometimes you need to do it beforehand, but I kind of like to do it all at the same point. It's just easier for me. And we probably only need like a millimeter on that. Perfect. That's it. Now we're done modeling the fidget spinner. But we're not there yet because we still need the center cap. So let's move on to that model. So here's the center cap model. I try to put the K-Tech K on there. Let's see if we can show that sketch. No. There it is. But I was having trouble manipulating the sketch to rotate it or shrink it the way I wanted it to, so I just went with the least amount of resistance, but it kind of ended up being a little bit weird looking. Okay, anyway, here's the cap. The way this is designed to work is to fit into a mating cap, or you print 2 of these caps out and they mate to each other. You get these ridges here interfacing with these, and that makes a nice tight locking interface. It can be removed without damage, so if you needed to like make a new version of whatever image you want here or plane or something, that'll be really easy to do. So I found that when printing on a smooth PEI sheet like Prusa has, that it makes this middle part slippery. so you don't have anything to grip onto. So having something like a letter printed on there or some kind of graphic cutout is good, because that'll give you, grip, obviously. If you're printing on a textured PEI sheet, you probably don't need this. Another thing you probably could do is create a little divot in here, some kind of concave feature so that your thumb fits in there. But this was easy enough for me, so that's how I've done it. All right, enough of that. Let's get into how to model this. Let's create a sketch. I'm going to sketch on the front here. I don't need, well, yeah. Let's add in this line here, and this is going to be a symmetric line. So this is kind of cool. Your line type, you can do construction, of course, but if you want to create a symmetric dimension about that construction plane or construction line, you actually want to do a center line. So that'll make it construction. That'll make it construction, but also able to be mirrored. So we're going to need that in just a second here. Let's start, let's do it up here. I'm going to do this a little bit differently. Okay. So that's the general layout that we need, but now we need our dimensions. So we'll go ahead and dimension those. We'll start with this leg. This is a 2 millimeter wide leg. This is 0.5. This is just a little interface with the, oh, that should be vertical. This is a little interface with the bearing so that this area here can spin freely and not rub against the bearing surface. Let's dimension this leg. This leg should be 5.75. Move it over, and I actually want these to be vertical with each other. Okay, that should be enough of that. Now we need to dimension the rest of this, so this is how you can do that. It's a very, very useful feature when making a revolve part, but you want to design to the diameter of the revolve surface, not the radius. Something SolidWorks does very well, and Fusion does as well. It looks like I didn't care much about dimensioning it that way symmetric. The overall should be 24. Now that should be a fully defined sketch. One thing I don't like about how Fusion handles sketches is it's not obvious whether the sketch is fully defined or not. Maybe I'm just missing it. I am still a new user. But it would be nice if, maybe someone in the comments can tell me how that works. But it'd be nice to see exactly when your sketch is fully defined or not. Anyway, so finish that. We don't actually need this for revolving the sketch. We'll use an axis for that. In SolidWorks, you either need to select this line or this line as your axis of revolution. So it's kind of nice that Fusion will let you do it this way. Here's the revolve. It actually picked up on the sketch that time. Yes, all of those are correct as default. I'm going to add in my fillet here right away, and that's like a 0.5 fillet. What kind of fillet was that? Okay. Sometimes, like in SolidWorks, you'll get the whatever your previous selection was as your new default. Sometimes that's nice if you have to do a repeat same operation, but it can be a pain in the butt if you don't remember and you just zip through the operation and realize, oh crap, that was not the right version of the fillet I thought I was going to get. Anyway, I forgot I need to add an edge. That one. 0.5. Okay. The next step will be to create our cutout feature for snapping the two halves together. The way we're going to do that is just going to be a straight line here. Actually, those need to be midpoint. That should be 2. Bring this out a little bit. And I don't have to make a sketch, a reference sketch on this feature here. It'll actually recognize this edge as a boundary for this feature I'm about to make. So let's make our symmetric center line again, and then we're going to make these radiate out to here. Holding Control, selecting these two objects, and this center line will reveal that we can make it symmetric, so we'll do that for both of these. And then the final thing we need to do is dimension this angle, which should be 82. Finish that sketch. Now, select those two boundaries, and we want to go down. How far do we want to go down? 5 millimeters. All of these are good. I knew I wanted to cut because of the direction I took that feature. Nice. Now we want to make the teeth that go on here. So we want to select that face, select the sketch, pick that corner, pick this edge, and they are, I believe, 0.5 millimeter thick. Maybe it's 1. Yeah, 1 millimeter. 1 millimeter thick. We're actually going to create a pattern of these, so I'll just finish that sketch that way. Create a boss extrude. I think we also want it to be 1 millimeter high. No, 0.5 millimeter high. And we're going to add a taper to it. A taper of 30. And yes, we do want it to join. Oops. We want -30 on there. This will make it easier for the parts to interface with each other, or to, slide and lock in. Now we take this. We're going to do a linear feature selected, the direction. Yeah, that's good. We can kind of drag our distance here, and that is correct. 3 millimeter distance with a quantity of 3. Okay. Now that that's done, we need to take this feature, and this cutout, and we need to do a pattern, circular pattern on that. Now we actually don't want to mirror this because we need these to be 180 degree interlocking, so we don't want to just simply mirror it. That won't work. Then you'll end up with these grooves on a flat surface and it just won't fit together. So we're actually going to do a revolve. Pick our axis. I want to make sure I grab the right axis there. We just want it 2 instances, and we want to make it angle 180. Oh, I guess that is what I want. Full is good. Okay. Now you can see the way I modeled that, it made sure to create a cutout through there. And that's just to add flexibility to the part. I don't want them to be so rigid that they can't interface with each other. Okay. Finally, let's put a little chamfer on these edges. Help them insert into one another. I actually might want to change that a little bit. That might actually need to be a little bit bigger. Let's make it a distance and an angle, and we'll make it 1 millimeter at 60. Sorry, still a half at 60. Okay. Sorry about that. Okay, that's it. That's your center cap. I'll leave it up to you to decide how you want to handle this. But that's it. That's the whole part. Oh, I spoke a little too soon. We actually do want to add a small fillet in here. Stop it. Excuse me. Yeah, see? I remembered full round fillet. We want these edges here. And then the same edges on the opposite side. And that's just a 0.5. That will help add some material to this feature at the base so that it's not as easily snapped off if you're being really rough with it. All right, that's done. Maybe I'll do a video on how to do an assembly. I haven't gotten that far yet. I think maybe assemblies are made within one model, like you build, I don't know. I guess I just don't know. I will look into it. But anyway, thanks for watching. I hope this was informative and entertaining. And happy printing. See ya.